here we go. So our task was to determine special values of circular functions, and we had to come up with our own angles based on different reference angles. So for the first one, which corresponded with a reference angle of pi over 6, I chose 30 degrees. And from this, using the unit circle and the fact that it's a special right triangle, and we have our given ratios here, we know that cosine of this is opposite or adjacent, over hypotenuse. So that's root 3 over 2 over 1, which is root 3 over 2. Same goes for sine, except that it's opposite over hypotenuse, so that's 1/2 over 1, simplifies to 1/2 there. So for the next one, we had a reference angle of 1/4 pi. So this for me was 135 degrees. And it's the same thing as a 45 degrees, except it's in the second quadrant, which means this base value here is negative. So from there, using our ratios and our special right triangle, opposite over hypotenuse, root 2 over 2 over 1 gives us that value for sine. And then for tangent, opposite over adjacent, we have root 2 over 2 right here over negative root 2 over 2. And simple algebraic deduction gets us down to -1. And then for the next part, we had a reference angle of 1/3 pi. And for this, I chose 240 degrees, which is now in the third quadrant. So from there, we know that both side lengths are negative, and this is essentially just a 60-degree triangle here. So for cosine adjacent over hypotenuse, we have -1/2 over 1, which is simply -1/2. For cosecant, get a little tricky here, we know that cosecant is the opposite of sine. So sine here in this situation, so it's the opposite of sine. So sine in this situation is negative root 3 over 2 over 1. So now it's 2 over root 3. And from there, we can simplify multiplying the root 3 over root 3 and gets that to -2 root 3 over 3. Okay, so the last step, we had a quadrantal angle. So from this, we know that the unit circle has the points and everything around. This one's 90 degrees, in particular 0, 1. However, those points are developed by using the limit theorem, and essentially as theta gets closer to 90, like for an infinite amount, then the cosine will be 0. And same thing for the sine going towards 90 as well. It will get closer to 1. So we're looking for cotangent in this problem. So why would I go through all that? So to find cotangent, we need tangent. So by doing that, we have sine over cosine, which is 1 over 0, and tangent's undefined. We don't really care about that, other than cotangent will now be 1 over tangent. Therefore, these will be flipped, and cotangent will be 0. From there, we also need to know how to get to what do we need? Get to cosecant, so for cosecant, it's 1 over sine. So simply because we found that sine was 1, it's 1 over 1, which is 1. So that's how you do all that jazz. Skill 3.